This is the video solution to an equipotential example problem. A 9 times 10 to the negative 6 kilogram particle of 5 nanocoulombs approaches a negative charge of negative 10 nanocoulombs. It travels from a potential of negative 45 volts to negative 182 volts. If the initial speed was 1,000 meters per second, what is the particle's final speed? So here's my strategy. I'm going to determine if the potential energy is lost or gained. So as it approaches, I can see that it's going to be attracted, so it's going to gain. I'm going to use the conservation of energy with the initial energies equal the final energies. And the amount of potential energy lost or gained is found from the work, which is equal to QV, where Q is a moving particle's charge. So in other words, potential energy is lost because the positive and negative charges are attracted to each other. It's also lost because the moving positive particle travels from negative 45 to negative 182, which means it's going to gain kinetic energy because it's traveling to a lower potential. So the potential energy that's going to be lost is going to be equal to the work, which is Q times the change in voltage. That's the difference in two equipotential lines. So 5 times to the negative 9 times the difference in potential is equal to negative 6.85 times to the negative 7 joules lost. So the kinetic energy that I start with is equal to the change in potential plus the kinetic energy at the end, or in other words, it's equal to the work. So 1/2 mv squared, the initial one, plus a negative Q times delta V equals 1/2 mv final squared. It's negative because potential energy is lost in this process above. So if I solve this for the final velocity, putting in all my numbers, I get 39,000 meters per second. Another way to look at this is I look at the original kinetic energy and then I just look at it and say, oh, well, the charge is either going to be attracted or repelled. If the charge is attracted, it's going to gain QV. If it's repelled, it's going to lose QV. So the initial kinetic energy plus or minus QV equals the final kinetic energy.